All right, so you're all aware that the internet has this huge amount of information available, and we're going to be able to access that through Python. But first, we need to know a little bit about how the internet works. So first, you need to know that every computer that is available on the internet has an IP address. That's for Internet Protocol address. That's one of the things that makes the internet what it is it's an interconnected network of computers. And there's only one internet. It's international. It's all those computers are connected together in one internet. It's incredible. It's by far the most important thing that has happened to communications in modern history, because all these computers are connected, all these people can talk to each other and exchange information. It's amazing. If you grew up with it, you might miss how amazing it is compared to having to go to libraries to find information, or do phone calls to talk to folks, or from my grandparents' generation, I have to write letters to talk to folks. The world has become a smaller place. Communication is happening much faster. I think it's mostly been for the positive, but of course there's been some negatives with it. So the idea is you've got this network of computers. Now also, that's the internet, and we'll talk about the web in a bit, because the internet is separate from, or not separate from, the internet includes the web, but it's more than the web. Your cell phone runs on the internet. Your automatic teller at the bank runs on the internet, but they're not on the web. And we'll talk about the web in a bit. So remember, the internet is the interconnected network of computers. Every computer has an IP address. Now, you probably would not be very happy if you had to type in a number like this every time you went on the web and wanted to go to somewhere like Google. So they created what are called domain names, okay, like www, which stands for worldwideweb.google.com. So that's their Google, and then it's part of the company bucket of domain names. So this is a domain name. This is actually just converted into IP address. When you type in www.google.com, that is sent to a server. The server comes back with an IP address, and then your browser accesses the Google servers through an IP address that looks a lot like this one. Different numbers, of course. So IP addresses, domain names, that's how we get to each of the billions of, well, hundreds of millions of computers on the internet. It's a crazy number of computers now that are all connected on it. Okay, now the IP address is typically hidden from you, so don't worry about it. It's the domain names we usually access websites and other internet resources. Okay, the way the internet works, you've been doing this for a long time. If I go up here and I'm looking for something like Google or HSU, if I type in that domain name, that'll get converted to an IP address. The browser gets, like here it's Chrome, gets back an IP address. It then goes to that IP address, makes a request to that IP address to get information. The server at that IP address then returns back a response. And those words are very important. They're specifically used in the transfer specification, which is called HTTP, or Hypertext Transfer Protocol. You used to be able to see it up here. If we type HTTP:// it can look like that. That stands for Hypertext Transfer Protocol. Okay, they hide it to try and make it friendlier. But part of that protocol is that the client, which is our browser running on my computer in this case, makes a request. The server then returns with a response. The request in this case is this URL, or Uniform Resource Locator. Every web resource will have a Uniform Resource Locator. We just call them URLs. Okay, send it, the request goes to the server returns a response. The response in the case of this web page, or the Humboldt one, is an HTML file, hypertext markup language, or HTML code, which we'll talk about some more. Okay, this request can be a variety of different things, and the response can be a huge variety of things. It can be an HTML page, it could be XML, it could be a JSON file, it could be an image. It could be some secret binary code, because the military also uses this. Not exclusively, but they do work on the web, especially now that it can be secure through the secure sockets layer, which is what's used when you go shopping. And yeah, there's a bunch of acronyms here that are going to be on the quiz. Okay, so notice that when we put something into the URL here, it can look like this. First part is HTTP, then there's a colon // then there's a domain name. Domain name becomes an IP address. Okay, we've got everything we need to talk to the server now, but we need some additional information to send to the server to tell it what to do. So if we go into Google, and we search for something like Python internet, okay, you'll see that what was put in here is a whole bunch of strange stuff, but there's the word saying I want to do a search, and here's the question that I'm asking. That's what Q stands for. And oh, look, there's Python and internet, and a bunch of other stuff, which is fairly typical. That's why I don't really show you these a whole lot, because yuck, they get really complicated, okay? They can be fairly simple as well, just like when you put in, you know, when you just go to look for a domain name, Google Maps, it just changes to google.com/maps. Ooh, and for some reason when I click there, it puts in my IP address. Interesting. All right. The basic structure is pretty simple, and we build a whole lot of complicated stuff on top of it. So HTTP, or Hypertext Transfer Protocol, is used for the web. The web is the web of web pages. Okay, so like this is a web page. It's linked to other web pages. Like these are all links to different web pages. That's what makes the web of documents that is the World Wide Web. Okay, so the web is all the HTML documents that are linked together. Now that's formally, we don't always use the terminology really carefully, but the internet is the computers that are all hooked together. The web are the HTTP documents that are hooked together. Now there's a whole bunch of other stuff going on in here, which you may have heard of as the dark web. Okay, there's nothing dark about it once you're a developer, because all the documentation is there for how to talk to the dark web. And it's just that there's other stuff happening, like your ATM or your cell phone, or anything else that doesn't have a web page but is talking over the internet. And there's lots of things going on there. Some of those are file transfers, which can be with FTP, or the File Transfer Protocol. Some of those are mail. Your email goes over the internet, not the web, through SMTP or another mail protocol. Okay. There's a whole bunch of different protocols out there. And in fact, there's protocols on top of protocols on top of protocols. These are referred to as network stacks for the most part. You don't have to worry about anything other than HTTP and IP addresses, because we're only going to hit a certain level of the internet. If you become a network specialist and start working in that and more intensely, then yeah, you're going to have to learn more about network stacks. Mostly I'll let the IT folks worry about that. Now, okay, we've got our domain name, and then we've got all these things. Now you may notice, as opposed to Google, this might start to look familiar. Okay, that's actually a file path, right? After the domain name, you can see up here, here's the file path for this HTML document. In other words, there's a special folder on my servers. It's called www.root, or the root of our World Wide Web folder. In there's a folder called OLM. There's a folder called Courses. In there's a folder called GSP 318. And in there's this HTML file. Of course, there's other GSP folders, GSP 270, 470, etc. Okay, and there's other courses, and then OLMs are done for different years. So, important thing is this is just a file path to a file. That's all. And that might be the end of it, except, as you saw up here with Google, we can also say question mark, and then we can add other parameters. And this is how we not only talk to a web page, but we can also send it parameters so that we can do things like search or add and remove things to carts, shopping carts, and a whole bunch of other stuff. And the question mark is what ends this. Okay, it goes after the file you're looking for. Then there's a question mark, and then you can add additional parameters after that that'll go into that page, and the page can look at them and decide what to return, and if there's any other action like maintaining a shopping cart for you. Okay, now As we move into the internet is another one of these areas where we tend to get a lot of errors, and often they're difficult to understand. And we're also just reaching the point in the class where you need to be doing more exception handling. Really, all final Python code should have exception handling in it. I'll talk about why in a second, but let's just do this really quickly. And you can see that if we try and divide 12 by 0, we're going to get an error. Okay, it's not where I expected to get it. Oh, missing parentheses. I need to fix that. Okay, that's from an older version of Python. Python 2.7 did not require parentheses, 3.0 does. So, all right, built-in zero division error, division by 0. Okay, if this happens, right, we can immediately see division by 0, we see it's on that line, we know what to fix. But your user may not, especially if this is buried deep down in your code. You might want to catch that and put up a different or improved error message. So if I comment that out, I run, okay, I'm going to try this, okay, and because it's an error, it's going to create an exception. It's going to jump into this exception block and print that the error has occurred. In other words, I'll do this, and what you'll see is that we're about to do this. It's an exception. It jumps over everything is okay. So it immediately will exit out of this block of code and jump down to your exception, and then you can do whatever exception handling you need to, and then your program will exit. If, on the other hand, we don't have an error and everything is fine, it will just continue through your try block, and then it'll exit. Okay? So, very important to do exception handling. Now, one of the problems is, again, these error messages are often challenging. And what we might want to do is not only add some a nicer error message, but also include the information from Python. Okay, so here what I've done is generated an error because I've taken a string, tried to concatenate it to a 1. We need to have format around that. So we've got an error, and I've just added a nice string in front of it to say, sorry, an error has occurred, can only concatenate string, not string to ints. Now, this isn't a great example. Another example would be like if you were trying to write out a file and you got an error on the file, you might want to say, hey, there's a problem writing this specific file. So you can make a nice friendly error message, and the user knows to go look at that file or that folder and see why it can't write to it. So a lot of different places where we want to improve our exception handling. Now, as a developer, you may also want to get additional information on where the error occurred. And that gets a little more complicated. We need to bring in sys and traceback. And when we run this, you'll see that it dumps out a whole bunch of information, some of which you're already familiar with because this is what Wing will put up, okay, to tell you which line your program failed in. But if you run it through the command line or it's running as a background process, you won't necessarily see this information. So this code allows you to capture that information, and there's a whole library called traceback set up for you to be able to get this information, and then you'd either print it or save it to a log file so you can get to it later. And I've even written code that would email me the errors when my servers were having a problem. So that's that.